I come here representing an industry based on radical new technology. Now, it was radical and new about 120 years ago, but it was radical at its time. Motion pictures, when they were new, was a big new technology, but then for about 100 years after the introduction, not a lot of change. So today what I'd like to do is take a look just for a bit at how technology got us to where we are in the motion picture business, what the technology holds for audiences, and what it holds for the people who create the experiences that we all share. Now, the Lumiere brothers patented cinematography back in 1895, and the audience wasn't prepared for it. I remember reading accounts of how people jumped back in terror when they saw the train coming at them because they didn't know if they would be hurt or if it was real. Then Thomas Edison in 1896 followed with the first projection systems that were practical in the US. And then around the turn of the century, films began to develop a narrative structure. And then the jazz singer represented the addition of sound in 1927. And throughout that era, they were experimenting with color, first with Technicolor, with hand-tinted prints, and then Technicolor developed its processes in the 1916, 1930 era. And then finally, modern color film, as we know it today, came around in about 1950. But nothing about the process of how you made a motion picture fundamentally changed in all that time. You would shoot a raw film, you would send the film to a lab, you would develop it, you would make prints of the negative, and then you would cut those prints and splice them together until the story was told the way you wanted it. And then you would go back and you would cut the negative to match the edited version, and then you would make prints of that finished film and you would ship them and they would go to theaters, they would project them and you would watch them. Nothing really changed about the process of how you made and distributed and viewed motion pictures for over 100 years. You could have worked your whole career in the motion picture business. Your children could have worked their entire career in the motion picture business, your grandchildren and maybe even their children, and nothing fundamental about the process would have changed. Television developed in a parallel universe. Now, television knew about film, but it was always on a separate track from the... That wasn't supposed to do that either. There. It was always on a separate track from the theatrical experience, and it was always trying to capture something of the theatrical experience and bring it to the home. In the beginning, television started out, as you see, 4:3 pictures in black and white. That's what film had done. That was what the motion picture looked like at the time. And remember the movie The Last Picture Show, if anybody recalls it from many years ago. It's told the story of what happened when television came to be in the US, and audiences started to stay away from the motion picture because they sat home and watched TV. So the movies had to react, and partly in response to that, color movies became much more mainstream. But then the color TV system was introduced in the US in 1953, and that advantage went away. So theaters had to respond again, and they started out doing 3D and Cinerama and CinemaScope and surround sound. And then color television was making TV in color as well, and they used a camera called a TK41 that weighed 425 pounds, that cost about $100,000 in 1960, and that made the best color pictures available. And if today your cell phone made color pictures that looked like the ones that camera made, you would throw your cell phone away because the quality was so primitive. TV quality was so different from film that there was very little crossover between the two media. And over time, television, because it had a lesser problem working with lower resolution pictures and smaller screens, began to do more digital processing. And so we started processing and manipulating pictures digitally in television in the 1970s. We started recording digitally in the 1980s. And then engineers were working on the electronic capture and display systems, trying to recreate the theatrical experience and replicate motion picture quality. Now, that early HD TV was analog, but high-definition television as we know it today grew out of that effort. It of course brought two key things from film. The widescreen aspect ratio that we see today and surround sound. And high-definition television became what we call 2K, 2,000 pixels by 1,000 pixel. That described what we commonly today see as high definition. So theaters continued to evolve as well. And so stadium seating became the norm, bigger screens. And the audience then now is placed closer to the screen because in stadium seating, the room became a square. And digital projection was added, and then something really new, 3D again. Now, these efforts to create HD TV were going on in the 60s and 70s, so today's HD TV experience emulates what the theatrical experience was about 30 years ago, when movies were like this or in the theater. Now, early TV was seen as a small image floating in the distance, and your mom used to say, don't sit too close to the picture because they were concerned about radiation from the cathode ray tube, but you really didn't want to sit that close anyway because the picture was made up of lines and scan lines, and you could see the elements of the picture and took away from the experience. So as HD screens get larger and viewers sit closer, our eyes are capable of seeing more detail on our modern screens. So that kind of brings us up to date today. So digital processing has become the norm for HD TV, certainly, and HD TV and modern cinema now are starting to share the same elements. In fact, early digital cinema had less resolution on the screen than today what we see in normal 1920 by 1080 HD. So what does technology hold for viewers? Well, depending on where you sit, the eye is capable of seeing more than 2K, more than HD, and many early converted theaters are 2K theaters, meaning that the theatrical experience in many places is essentially the same picture as HD TV. Now, it's not how big the screen is, it's how much of your field of view the screen fills. And that's the critical element. People talk about, I don't need certain resolution because I have a small screen. It's not about the size of the screen we talk about. We talk about how much of our field of view does the screen fill. Well, back 30 years ago when HD TV was being conceived, we saw pictures that looked about like this, from the back of a theater or the middle of a theater. And today when we go to a modern theater, the picture fills this much of our field of view. That's a fundamental change in our relationship with the screen. So sitting that close to the screen, whether you're at home or in a theater, allows you, if you're watching HD TV, to see the structure of the picture, to see jagged lines, to see text that doesn't look clear, to see the picture as if looking through a screen. In the most modern cinemas today, we're approaching an experience where the resolution on the screen and the image we see is designed to most closely match what the human eye is capable of experiencing. This puts a lot more data on the screen and creates a lot more processing requirements. So just to put it in perspective, you can change the screen size when you're designing the experience, and you can change the distance you sit from the screen, and you can change the number of pixels, picture elements you put on the screen. But the one thing that you can't change is the human visual acuity of your audience. And there we are. So this is an eye chart, and when we look at an eye chart, what we're seeing is actually a test to see if we have normal vision. And in the US, we talk about normal vision as being 20/20 vision, meaning I can see at 20 feet that which I should see at 20 feet. 6'6", in most of the rest of the world is 6 meters, the equivalent. Now, the point about this eye chart is that the smallest elements on the eye chart are the ones that we're measuring. And on the 2020 line, or the 6'6" line, the amount of information, the width of the letter of the bar in the letter E that you see is equal to 1/60th of 1 degree of the field of vision that you have. 360 degrees to surround you, 1 degree, 1/60th that. That represents the amount of information, or the width of that line. Now, when you sit in front of the screen, you would kind of like to have the picture be such that you could not see the smallest element that's in the picture. And so, if you do the math, it works out that when you're doing cinema and sitting in the modern cinema theater, the higher resolution than standard, or than high definition, or than what we call 2K is required to match what your eye is capable of seeing with what is on the screen. And if you have less than the amount of information your eye is capable of seeing, it appears as though through a filter, or it appears that there are jagged edges, because in fact the picture is a mosaic made up of squares. So, it turns out that sitting in the middle of a modern theater, the resolution your eye needs to see to match most closely to it is called 4K. That's 4,000 pixels across, 2,000 pixels high in round numbers, which is 4 times what you see in high definition television. And that is the amount of resolution that's necessary to match what the average person's eye is capable of seeing. And if you don't, the picture breaks up into the pieces and you start to see the components of what's on the screen. So 4K technology was designed with a simple goal of trying to match the theatrical experience to what the human eye is capable of receiving. It's also a better representation of what was on the negative of a 35 millimeter film. And it's interesting, most people don't realize, but 35 millimeter film that we were using for that 100 years of production, and still some cases used today, is capable of more resolution than high definition television. They set out in high definition television to replicate the experience of watching a 35 millimeter print, but the negative had to be printed, and when there was the printing from the negative to the positive, there was a loss of resolution in the picture, and then the mechanical projector was never stable enough to keep the picture in one place, so the picture was always moving around the screen as it was projected. The result of all of that was that there was considerably less information being received by the viewer than there was on the negative. Today, using 4K systems, we capture all of what is on the negative and can put it on the screen and give pictures new life. But it takes 4 times the data to manage it, and until recently, people have not built the systems that were ready to process 4K. Now, TV has always sought to emulate the theatrical experience with every step as we've been through history. So it's reasonable to think that with TV, people will also come to expect the image that an image that fills their field of vision will be able to provide it without revealing the structure of how the picture is made, just as we now see in theatricals, so that it's reasonable to expect that 4K will move also to the home. And so we've been working on 4K systems and building a library of 4K films, and these pictures are more immersive and transparent and more accurately reproduce the world that the director has envisioned, whether it was real or imagined. We now have a camera that is capable of matching the dynamic range and resolution of film. It's called a F65, and as I said, 4K is now the archive standard for classic movies like Lawrence of Arabia and Taxi Driver and others, and also things that are shot on film even today, like the recent film Moneyball, have been done at 4K. And for Next Generation, After Earth, which is a new motion picture by M. Night Shyamalan, is being shot with the F65 and is the first film to be shot really in 4K using the new camera. And we know of at least 4 other films that are also in production at this time using the camera. So the studio and the electronics company hosted classes to train hundreds of industry professionals in how to use the camera systems. The point of the technology is to give the filmmakers the tools to realize a vision. And that's the shared goal for both the studio and the electronics company. So what does the new technology offer for creators? Well, these are the filmmakers who see the movie in their heads before they can transform it into something we see on screens. At the end of the day, the tools and technologies should be transparent enough that filmmakers shouldn't have to work around them, that technology should work around the filmmaker. Systems need to work at the speed of thought and not make the creator wait on the technology to catch up. The classic example is dailies, where in film, you shoot the film, you send it to the lab, and you wait till tomorrow to find out what you got. That's gone away as we've gone to electronic production, but it's a classic example of having the creator work around the technology. We talked about how nothing fundamental about the process changed for the last 100 years, but in the last 10 years, everything has changed. Digital revolution is nearly complete. Tools have grown up in every phase of production, but they grew up in islands. And so the movement of the data from one digital process to another through the production process has been a hindrance to smooth operation. And so today we're working on integrating all of the islands into a seamless file-based architecture that allows us to work up to 4K without having to download material, record it, upload it, and then transport it. So it becomes a giant data management problem to take the image from the camera, where we're shooting 20 megapixels, 16 bits per pixel, 24 to 120 frames a second, and then distill it down to something that you watch later on your cell phone. And that is a data management problem that we're addressing. So the next step we see for our industry is to leverage the connectivity and economy of scale that the cloud has to offer, discussed earlier today. We see media cloud services as a way to change the way creatives collaborate, to bring the elements of production and distribution to the cloud so that it allows collaboration without regard to geography. Today, we may shoot a film in Costa Rica, we may edit it in Pennsylvania, create the digital effects in New Zealand, color correct it in California. Today, we move materials. Tomorrow, we see the seamless transport of all of that information across networks. Visual effects, color correction, all elements, production, post-production, and all in 4K. Transformation of the industry into its current and future state where technology supports the creative process is the goal, and it's underway. Technologies that get in the way of storytelling do not serve the creative community or ultimately the audience. And in the same way that display technology should adapt to the audience's eye, filmmaking tools should be transparent and adapt to the creative community's needs. At Sony Pictures, we're developing tools to support the creative process to transform ideas into images on the screen and to make new technologies that respond to demands of both the creative community and the audiences they entertain, to make the technology the servant of the human experience. Thank you.